Alright, in this video we are going to learn how to find the range of a function from a graph. Alright, so I think many of you have done this already in previous years, but I do want to get something official down as just something to refer back to in case you ever need to, if you forget what range means. So before we do that, recall what a function is. Recall that a function is a rule that assigns a unique output to each input. Okay, so a function is like a machine. It has inputs and outputs, and it's a rule that assigns a unique output to each input. And the set of all inputs is called the domain of the function, and the set of all outputs is what we call the range. Alright, so today we're going to focus on finding the range. So I'm just going to do one example. Okay, so let's determine the range of this function f of x equals 1 over x minus 3 plus 2. Okay, so I'm going to spare the details on the graph because the point is to be able to look at the graph and just get the range, but the graph is going to look like this. So I've got an asymptote at 3. I have a horizontal asymptote at 2. Okay, and let's see, anything else of interest when I plug in 0, I get a number a little less than 2, so my picture is going to be doing this. Okay, so there's my graph. So how do we talk about the range? Well, really, all you need to focus on is what it means, what the range means. It's the set of all outputs. Okay, so in another video, you've taken a look at analyzing a function to determine its domain. Here, we want to determine its range. So one thing you can start doing is think, okay, and you just pick a number, like 6. Is 6 in the range? So I'm just going to go up here to 6. Is that an output value? Well, I claim that it is because if you go to the right here, you'll hit a point on the graph, and it looks like that is an output for this input down here. I don't really care what that input is to answer this question, but just note that, yeah, 6 is in the range, because if I plug in this little x value here, whatever it is, I will get an answer of 6. Okay? How about negative 2? Is negative 2 in the range? Well, negative 2 is down there, and if I go over to the right, I see that negative 2 is an output for this function. It is a point on the graph for some input value or x value, and it looks like in between 2 and 3. Again, I don't care what that is. Okay, so you can't possibly keep doing this over and over for every single x value. So really what you want to consider are there any y values, any outputs that are not in the range? In other words, are there any y values for which I can't move horizontally and collide with the graph and determine a point on the graph? Well, if you look carefully, it looks like at 2, I have what's called a horizontal asymptote, and if I go way to the left, indefinitely, I'll still never hit the graph, and if I go infinitely to the right, I will never hit a point on the graph. So 2 is not an output value for this function, so it's not in the range. Okay, but everything else is. If I go past 6 up to 1,000,000, 2,000,000, by nature of this graph here, those are arrows, of course, by nature of the graph, I should be able to play the same game and find another point on the curve. And same if I go down past -2 to big negative y values, like -1,000,000, because this function is approaching negative infinity as x approaches 3. So the only problem is 2. So our range, we're going to say, is everything except for 2. Now, the notation we use is we say, okay, the range goes from negative infinity, so I can take all giant negative x y values, all the way up until 2. So 2 is not in the range. So what I'm going to do is put a soft bracket here. That means all numbers up until 2 are in the range. Okay? So you got to skip over 2, and then we proceed from 2 on to positive infinity. Okay? So this is one particular example, but just keep in mind that the way you analyze the range, analyze a function to determine the range is the same. It's the same mental process regardless of the picture. Okay, look for those bad points. I'm going to give you one more example to just to follow for determining the range. So let's determine the range of y equals g of x equals 2 sine of x. Okay, now again, I'll get the graph down, and we just want to be able to analyze it based on the graph for now. Okay, so sine of x, 2 sine of x rather, it's going to look like this. Okay, so there's my graph. So I'm going to play the same game I did above to determine the range. Let's start thinking of y values that are outputs for this function. Well, for instance, 1 is an output because if I go to the right, I see that that point there is a point on the graph, and 1 is an output for whatever this particular input here, whatever that x value is. Notice that 1 is also an output for that x value here. Okay, it doesn't really matter though. That the fact that there's more than 1 in this, in doing a problem like this, doesn't matter as long as there is 1. There could be more than 1, but as long as there's at least 1, we'd say 1 is in the range. So 1 is in the range. Let's think of another number that's in the range. How about -2? -2 is in the range because if I go to the right here, I see that -2 is an output for the input 3 pi over 2. It's also an output for the input negative pi over 2. Okay, but the point is it is an output. Likewise, 2 is also an output. And I think we can argue, of course, that everything in between -2 and 2 is an output, including -2 and 2. But 4, for instance, is not, because if I go over to the left or right, I have no chance of ever colliding with the graph. Okay, 4 is not an output for this function. There's no point on the graph that has a y-coordinate of 4. So our range is -2 to 2. Hard brackets on the -2 and the 2 because those are in the range.